Hi, welcome to one of everyone's favourite segments, Mailbag Monday. I've been inundated with mail. I don't even think I can fit it on my 30mm wide angle lens here. Crazy. Anyway, I'm going to try and get through as much as possible. If I don't get them all open in this one, sorry, they'll come eventually. So, first one, here we go. It is from All Your Tech Stuff, Nathan in Bowral, here in New South Wales, home of the Don. Australians will know what I'm talking about. Thank you very much, Nathan. Let's have a look. I actually forgot. I feel naked. Forgot my little mini champ knife, so we're going to have to use this cyber tool today, by the way, but these ones are easy to rip open, so let's get in here. And ta-da! Oh, screwdrivers. That's right. He clued them up. He heard that I had lost my screwdrivers, so he's sent me a couple of new ones. That is absolutely brilliant. Thank you very much. They are WIHA brand. I've never heard of them, but they are made in Germany. Brilliant. There it is. Oh, brilliant. Phillips #1 and #2 point. Thank you very much. Can always do with screwdrivers here in the lab. That's fantastic. None of these cheap Chinese stuff made in Germany. Brilliant. I love it. And it's marked as slim. Look at the quality of the tip on that. It's got some oil on there rubbed in by nude virgins at the factory in Germany, I'm sure. Oh, beautiful. Love a good high quality screwdriver. And there's Nathan's business card, All Your Tech Stuff. Check him out, allyourtechstuff.com. I love his last name, Bat. Brilliant. Next, this one was hand delivered to me from one of the students at the University of New South Wales at the show. So hello to all of the students from tons from uni in New South Wales. I don't know, I must be big at the uni in New South Wales. There were coming in there hundreds to the show stand at Electronics. Oh man, they're everywhere. Anyway, this, I think it was Mitchell, who I assume it was, who sent me this. He's designed, haven't opened it yet, but BlueSat dice kit. It's one of these electronic dice. It's a, a learning thing. Always wash your hands after soldering. Take care. All these safety tips. So it's designed for the students to. There's a resistor color code, how to solder. It's designed as a easy to use, like a beginner soldering kit. Through hole electronic dice. Really quite neat. There's the circuit diagram. It's got a 555 timer and a 4017 and a transistor amplified touch switch there. Excellent. So, no microcontroller rubbish in this. Doing it with a good old 555 and a 4017. I love it. Very old school, very 200-in-1 project kit. Oh, here we go. Whoop. All the parts have just fallen out. There's no baggie, but check out the board. Look at the matte black solder mask on that. That is beautiful. Oh wow, that is very, very nice indeed. It's powered from a CR2032 battery. Oh, I do like the black matte. I'm usually matte black. I'm usually not a fan of black solder mask, but the matte black one can look very good. It makes your tracks impossible to see, but who cares? It's a very sexy finish. There you go. There's an attempt at a close-up on that, and it just looks beautiful in real life. It's just absolutely stunning. Matte black. I don't know where they got the board from. Maybe you can tell us, leave it in the notes there. And what I really love is, that's presumably the Uni of New South Wales electrical engineering symbol, and you touch that and it's actually a touch switch, hence the gold-plated contacts there. It's not just for show. Touch it and you get lead dice. I'm going to have to build this sucker up. Wait for the end of the video. And I've just got a basic postcard here. Nothing else with it. Brilliant. I love postcards, love collecting them. Dave, I was bit by the EEBug about 6 months back. Pictured on the front is a board from a kit I designed. It's an inexpensive $15 Arduino clone kit designed as a single-sided board. My goal was to make a simple to understand, easy to build Arduino clone. Excellent. Thank you very much, James from Ogden in UT, which I believe is Utah. There's a beautiful looking postage stamp. Look at that, from, I think that's Lancaster County in Pennsylvania. Cost a whopping $1.05. And why is there a little plane on there? But look at that, beautiful, picturesque. Pennsylvania, is that like an Amish little horse-drawn carriage or something there? Sorry if I've got the wrong state. I'm probably being stereotypical there, but I love beautiful countryside like that. Ah, fantastic. So let's have a look at the Arduino board James has designed here. Look at this. It's got one of these, it's printed by, you know, some mob, printed by simplypostcards.net. You can upload a couple of images and it puts them in a wanky little, you know, display form factor like that with, you know, individual pictures like it's on a deck or something. But I love a single-sided layout. I'm a big fan if you can get your design down to a single-sided layout with no links. The goal is to, the holy grail of PCB design, single-sided with no links, or, you know, double-sided with no links if it's a complex board or something like that, without having to resort to internal layers. Then that's just brilliant. And I can't actually see any links on there. There might be one or two on the board, but anyway, brilliant. Well done. Thank you very much, James. And we have another one from the US, Neil Greenberg from Smartboard. That's not Smartboard, it's Smartboard, if I'm pronouncing that correctly. And I had heard of these. He did clue me up. He was going to send me a couple of little adapter boards from San Ramon, or San Ramon, perhaps, if you want to pronounce it like that, perhaps, in California. I haven't been to San Ramon. I don't know where it is, but let's open this up. And Smartboard, they've been making quite a few adapter boards and things for a very, well, quite a few years now, and they're getting a very good rep. Here they are, a couple of Smartboards. Fantastic. Whoa, here we go, we've got a press release. Attention editor, for immediate release. There you go, Smartboard releases family of surface mount prototyping shields. Arduino users now able to use SOIC, QFP, QFN components on projects. Looks like they got 5 different technologies here. Smart Trace, Smart Bridge, Smart Module, Smart Developer, and number 5, Smart Board Easy. Brilliant. I like it. So let's take a look. Easy for ICs. They've got all sorts of stuff. So if you're looking for adapter boards, these Smart boards are, I've heard that they're the duck's guts. I've never actually used them myself. I was actually going to do a whole range of years back before the blog. I was going to do a whole range of adapter, SMT adapter boards, but then I delayed too long and the market was flooded with them. Seemed like every man and his dog was doing. Here we go. What do we got? Now you can hand solder practically any SMD components quickly, conveniently and flawlessly. This is their Reflow soldering process, a new patented, they've patented the thing, to make hand soldering surface mount components simple. There are 2 reasons it has been difficult in the past to hand solder components. First is hard to correctly place the chip on the pads and keep them aligned. Second is difficult to hand solder tiny areas. Smartboard's technology addresses both of these issues, making hand soldering components flawless. And apparently it's already got, I believe it's already got the solder on in the grooves or something, and the chip aligns in the grooves or something like that. So let's have a look. Now this is actually an Arduino Shield, like a prototyping shield for an SO footprint device, 1.27mm pin pitch, and uses easy Smartboard, easy technology, and like they've already apparently got enough solder on the pads that you just put your chip down. It sits in the solder mask groove on there for the pad, and then they've got these extra long pads on it, and then you just get in there with your iron and then you just push it. Apparently there's enough solder on there, then you put some flux on and there's enough solder on there to push back and make your connection. So you don't actually need any solder, you just need flux to do it. And I don't know why you know, how or why they actually got a patent for that. You know, there's nothing special about extra length pads at all for ease of soldering, or like they talk about grooves, putting the chip into grooves on the pads, but there doesn't seem to be anything, you know, it just seems like regular pads with just solder mask between them. So I'm not actually sure what's going on there. Now they do actually show that the board is supposed to have like little channels routed into it or something that the legs go into, but I can't quite see that here on the board. So you put the leg into it, it holds the chip in place, and then you push the solder back from the long pad after you put the flux on. There's enough solder on the pad to do it, but I don't know if they've actually routed a channel in there and then they've plated it inside or not. It's hard to actually tell. If I try and have a look under my Mantas microscope here, my Mantas Elite, which I haven't reviewed yet, sorry, everyone wants me to do a review of it, but it's hard to get the board on a real angle in there, but can kind of sort of see maybe they're in some sort of slot, but it's incredibly shallow if they are, so I'm not actually sure how they're actually doing that, or if it's a major advantage just compared to regular solder masks. Maybe they're just using thicker solder masks than normal or something like that perhaps. So I guess the proof is in the pudding here. Let's put an SO package chip on top there, and yeah, I'm wiggling that from side to side, and I'm not stopping that, that's actually stopping, but you do that on a regular solder mask board anyway, really, so I'm not sure, you know, what huge advantage they've got there in this groove thing, which apparently they've patented. I don't know, maybe they can give us some more detail on it, but it does sit in there pretty easy, and they tell you to tape down one side, and once you've got flux on there, just move the solder back and bam, you solder a chip on. As a point of reference there, here is a regular board I've got. This is a PCB cart board. It pushes off that way, but in this direction it certainly stops dead in its tracks due to the solder mask. So the Smart board is a little bit, seems to be better in that respect of the chip moving out of location or something, but yeah, I guess it's, you know, it's an okay advantage. I think maybe they've just got some extra thick solder mask there or something. And another US-based one, this time from Clifton Laboratories. Thank you very much. It says it's a radio, I think that says radio filter. Not 100% sure there, but anyway, let's crack this thing open and see what we've got. What do we got here? Oh, we have a graph. Jack Smith from Clifton Laboratories. Thank you very much, Jack. Aha, he's obviously seen my DSA video. Enclosed are two 15 meg low-pass filters. One is a single pi section Butterworth low-pass built according to the design I showed in my DSA video recently, but with a different physical layout and component choice, because if you saw the DSA video, you would have known that a lot of the parasitics I was getting in the response are due to the physical construction of the thing. If you built it, you know, dead bug free air style or something, it'd be much better than, and distributed capacitance, and you know, there's all sorts of methods to increase this thing. The 1 microhenry inductor is 17 turns of micrometal power iron core shunt capacitors, a pair of 100 path COGs. Second filter is an inexpensive Coilcraft P7 LP filter installed on a printed circuit board I made a couple of years ago. There you go. They are not the most mechanically sound bits of kit. Excellent. There you go. He's got some notes on this. The trick to good VHF-UHF response resides in proper component choice and mechanical layout. Part of that includes avoiding coupling between the input and output connectors. Absolutely, because then if you've got capacitive coupling between input and output, it bypasses your filter, and that can really ruin your day. As the homemade filter demonstrates one way of accomplishing that task, and in fact it turned out better than I hoped for, with a monotonic decrease in slope to almost 400 megahertz range and useful attenuation up to 1 gigahertz. Awesome, because if you saw my DSA video, it only went to about 75 or 80 megahertz or something before it just crapped itself. He's got some plots made with the HP Vector Network Analyzer. There's the low pass. There's the low pass filters from Coilcraft, which is included. That's the Coilcraft data sheet. And here you go. Oh, I love graphs. There you go. That's the Coilcraft response, and that stops at 1 gig. There you go. So that's 1 gig. That'd be 100 megahertz there. That'd be 10 megahertz. So there's your 15 megahertz there. Your minus 3 dB point at about 15 megahertz. That's 20, and then 30, and then boop, boop. But it does that recovery thing. There it is, just as my one did. You can't really avoid that with the Pi filter. Anyway, that's the Coilcraft one. But there you go. There's his one. The homebrew one, much, much better. Look at that. Once again, 1 gig stop frequency, so that it's a decade, so that'll be 100 meg. That'll be 10 meg. There's your minus 3 dB point up there at about 15 meg. And there's a bit of recovery, but it's only at, 600-700 megahertz or thereabouts before it starts to rise again and the parasitic effects start kicking in. So that's actually a really good response. So let's have a look at it. Oh, this is excellent. There we go. There's his homemade one. Oh, let's look at this. And that is absolute classic homebrew filter. You've got the made with copper-clad PCB like that, directly soldered onto the bottom. So there's very minimal capacitive coupling between input and output. You've got that huge air gap in there. There's no parasitics directly on the board because he's drilled a hole straight through the PCB like that, comes straight through into there, into the wound inductor in there, and straight to the output. And you could whack that whole thing in a box. You could have some, where's his capacitance, would be in there somewhere. Yeah, it's going to be hard to see that in there, but you can see the 1206 capacitor there, and there's one on the other side as well. So it's actually distributed on both sides, and you can actually get slightly improved performance if you tweak it a bit by you use multiple capacitors all the way around it, so you're actually not offset on one side of the connector. And it can be that critical if you absolutely, you're stroking your grey beard trying to get this thing to work, metaphorically, and there's a lot of art in designing and getting the utmost performance out of these RF circuits, especially, much, much higher frequency. I mean, we're only talking, we're not even talking a gigahertz here, so that's DC as far as the, the RF guys are concerned. But there you go. That's a nice little build. I rather like that. And if we have a look at the Coilcraft one here, here's the P7 LP filter board, and it's a little hybrid module. It's a little ceramic hybrid. Check it out. I love the little kink in the trace in there. Check that out. Tiny little kink in there. I like it. And that is a commercial Coilcraft filter, and its performance, as you saw, wasn't as good as this homemade beastie. It's available in 3-pole and 7-pole versions. So there we go. It's available in different versions as the Coilcraft, these commercial Coilcraft filters. So that's the 7-pole version, and you can see that this commercial Coilcraft 7-pole filter, even though it's 7-pole, isn't nearly as good as Jack's home-built one like that. Not nearly as good. I mean, its attenuation is much steeper, of course, because it's a 7-pole. Look at that. These are the same scale, by the way. This is 10 dB per division there, and the same scale on the x-axis stops at 1 gig. But you can see the difference in those responses. So thank you very much, Jack. That was rather interesting. And if you want to check out his stuff, go to cliftonlaboratories.com. We've got one from France this time. It's a USB PCB worth $5. I have no idea what type of USB PCB, but it's a Cocos Florin, or is that Florin Cocos? got it, you know, back to front. I've goofed that up before. Toulouse in France. Awesome. Hello to all my French viewers. And let's have a look. What's in here? It's got one of those red zip pull cords, which I failed to pull because I'm not that smart. Let's have a look. We have a little USB PCB. Should actually read the note first, shouldn't I? What does it do? It's a jumper. It's a USB micro to USB-A converter. Oh, this will be handy because it allows you, I haven't even read the note, but this will be handy because it allows you to measure the current. Awesome. It allows you to jump in there and disconnect the individual wires. Very niche. And it's from Yuritronics, or Yuritronics.com. There you go. Florin's his name, from Yuritronics. And included is a micro to USB-A bridge. It is not the most useful piece of electronics to have in your toolbox, but it proves useful for his current project. I'm using it to get current and voltage measurements, exactly as I said it would be useful for. For example, how much current I'm pulling from the USB port. Excellent, because I've had to do that many times. Like I've had to measure the USB current. I've had to chop up a USB cable and then I put it somewhere and I forget where it is. So the next project I want to measure USB current again. I've got to chop up another cable. Luckily I've got heaps of USB cables, but it's a pain in the ass. So this will indeed come in very handy. Thank you very much, Florin from Yuritronics.com. And is this a coincidence? But we have someone called Florian Rosner from Germany. And it's not Florin, it's Florian. If I'm sure I'm pronouncing that incorrectly, my apologies. He's in Ludwigsburg in Germany. I'm sorry, I haven't been to Ludwigsburg. I've only been to Hamburg. That's pretty much it. Hamburg and Lübeck. All of my German viewers will know what I'm talking about. Lovely little town, Lübeck. I liked it, and Hamburg's brilliant. It's great. What do we have here? One lithium-ion, lithium polymer charger. Let's crack it right open. Oh, get on out of there. There we go. Ta-da. Oh, it's tiny. Oh, look at that. Look at that. It's a USB. A USB lithium-ion charger. So it goes straight from the USB port, plugs straight in. It's got a little tiny 5-pin SOT 23. That's probably a little microchip one or something, and goes straight into one of those two-way connectors to charge your lithium-ion single cell, I'm presuming, single cell lithium-ion or lithium polymer battery. Terrific. It's the Lipo Nano. Great name. I like it. He's a robotics, Florian's a robotics student from Germany. Really likes my videos. Thank you very much. Thought might look at his first product that he's made. It's a portable lithium-ion charger. Made it for my little robots because it's really handy to charge them on the run with my notebook. Would you be so kind as to give me your opinion on this little device? Well, off the top of the bat, I can tell you it looks quite neat. I like it. Just a little compact form factor. It does its job perfectly. Plugs into the USB. There's no cables. Bam. Straight in. Great. Do you need a small but compact, very powerful USB single cell? Yeah, 3.7. Well, it's actually, I assume it's 4.2 volts charging. 3.7 doesn't actually, they're rated for 3.7, but they charge it. What's important is what they charge at, which is most of them charge at 4.2, plus or minus 1% absolute max. The better lithium-ion charger chips are like 0.5% or something like that tolerance on the constant voltage part of it. It's designed to be not much bigger than a wireless USB mouse dongle, still able to charge at a rate up to 500 milliamps per hour. With a small solder jumper, you can select between 500 milliamps closed or 100 milliamps jumper open. Not sure where the jumper is on there. We'll have to have a look, but there you go. Green, orange indicates that it's charging. Green indicates battery's full. And there you go. It does use a microchip, MCP 73831T, and one of the JST connectors. Great. Terrific. So if you're after that, take a look at his website, Tindy, www.ranger/liponano-1. Ah, there you go, end charge 4.2 volts. And there you go, the little jumper is actually a solder bridge pad. So you can't change it on the fly unless you've got a, you can hack it off, I guess. You could leave the solder on there, but there you go. And on the back there, it's got the little microchip fixed, a little 5-pin SOT23 with a couple of LEDs. I guess my only complaint would be it depends on which, I'm not sure, I haven't tried it, depends on which way the PCB sits up. If, of course, your notebook is designed with the connectors down, like that, you won't be able to see the LEDs. So I assume that it's going to go, assume he's thought of that, and it plugs in up like that. And you betcha, there you go, it's inserted the correct way, up, and you can see the LEDs. He's thought of that. Brilliant. And if you want to send stuff in, here's the address. Dave, that crazy Aussie bloke, Jones, PO Box 7949, Borkham Hills, New South Wales 2153, Australia, not Austria. And we have one here from H. Olsen, is it? From Ronny, I'm not quite sure, in Sweden. Hello to all my Swedish viewers. I won't mention Julian Assange. Electronic parts at... So I have no idea what's in this. We've got some stamps here. We've got some trees there. The Swedish krona, is it? I mentioned that. I think I've got that wrong before, but there we go. We've got some lovely trees and plants on there. And what else have we got over here? I have no idea what that is. Some microbial life or something? Or is it just like a zoomed in part of a leaf or plant or something? Not quite sure. Anyway, let's crack this thing open, see what our electronic parts are. Just got a bunch of random parts, or is there something? Another kit. Oh man, got so many kits. More kits than you can poke a stick at. It's the mini Modbus Rev C with standard screw terminals from heinrichsplace.se. Check them out. And there you go. Heinrich is from Ronneby in Sweden. Hi to all my viewers in Ronneby. I'm sure it's a nice place in Sweden, except for the Julian Assange thing. Let's not go there. Enclosed, you'll find a small kit I thought might come in handy. It's a little PIC-based controller board with the following hardware features: 4 opto-isolated digital inputs, 4 open collector digital outputs, 2 10-bit analog inputs, 0 to 5 volts. I assume that's just the ADC internal to the PIC, of course. 1 10-bit low-pass filter PWM output, 0 to 10 volts, 550 milliamp drive capability. So he's obviously just using 0 to 5 volts output, and then got a ×2 op amp on there. So clearly it's either there's an onboard DC to DC converter, or it's got to be powered from grade at like a 12 volt supply or something like that. The microcontroller is pre-programmed with firmware. The Modbus RTU slave device used in a point-to-point master-slave setup. It's not something you have to use when you can obviously reprogram microcontroller and firmware. Use a general-purpose microboard. For more information on the board, and visit the website at heinrichsplace.se. Follow the links to the MIDI Modbus page. I presume it's open hardware, and let's take a look at the schematic here. So the power supply, yeah, we've just got a, is that a, yep, 7805, 15 to 30 volt input, and we've got a 78L12 as well, both linear regulators. So yeah, it's got to be at least 15 volts input, because 12 volts output here, you need at least 2 volts. So it could actually go down to, oh no, it can't, because there's a diode drop is there as well. There you go. So what have we got? There's our digital inputs. Of course, they're opto coupler inputs. We've got our digital open collector outputs. That's just a UCL2003 or something like that. One of those open collector driver devices. Doesn't actually say that on the schematic. That's a bit of a bummer. I don't like schematics that don't have the actual part number written on the chip. Or is it there and I'm just blind? I don't think so. I don't think it's there at all. It's got the IC SP header, in-circuit serial programming header for the PIC chip. Bingo, there's our ×2 amplifier to give our 5 volts PWM signal a little boost there. It's just got a single pole filter, 0 to 10 volts output. and it's just a TS992 op amp driving that. Spare one tied to ground there. You probably shouldn't, ideally you probably shouldn't tie both to ground there, because the residual noise between the inputs can possibly cause the output to oscillate, in theory. Anyway, in practice, doesn't always happen. At the max 232 there, and we're going to pick 18 LF1 XK22. There's so many bloody picks. I don't know. Who knows? Anyway, it's got a setup jumper and some firmware. And here's the board. It's very nicely laid out, nice and neat. Most of the traces on the bottom here. It's all ground flood filled. Excellent. Well laid out. Everything's in nice alignment, grouped, beautifully labelled. I like it. Thumbs up. It's got a using the PCB as a heatsink, just flood filled to the rest of it. Presumably comes with a bolt to bolt it down, or maybe you could just solder the tab on there if you're so inclined. There it is. It's a ULN 2803 open collector driver. I thought so, but that's it with screw terminals. Very nicely laid out little board. There you go. So if you're after like just a little general purpose microcontroller board, check out the Mini Modbus. Thank you very much, Heinrich. Last and certainly least, perhaps, from Sungyu Logistics in Hong Kong. I don't know. I shudder when I open something from Hong Kong. Is it one of these, $1 chargers again, which I still haven't done the tear down and reverse engineering of that charger from last time, that are almost always a heap of crap. Anyway, not quite, Sungyu Logistics doesn't have a name on there at all. It's a electronics, go figure. And what have we got in here? It's another one. It's exactly the same. I've already got one. Oh man. Aha, this one is not a one-hung low cheapie. Designed by Apple in California, or so it claims. It's Apple Japan. There you go. Whether or not it's a genuine one, I'm not sure. It's got the model number A1265. There you go, 5 volts at 1 amp. So that will make an interesting, where's the Apple logo? I don't know, are they supposed to have it on there? That's an interesting comparison for when I tear down the other one, if this is a genuine one, and we'll be able to compare the one hung low cheapie, which is absolutely going to be a steaming pile of dog turd, I'm absolutely sure of it, against if this is a genuine one. It'll be interesting to see the drastic, I'm sure, difference between a one hung low cheapie and a genuine designed by Apple in exactly the same case. So here it is. Here's the two of them. Here's the genuine Apple one, and here's the one hung low cheapie, and we're going to rip these suckers apart, and I guarantee you this one, steaming pile of dog turd. And if this is a genuine one, it should be a lot better engineered. Feel any weight difference in that? Oh, this just feels higher quality. I don't know. Anyway, that'll be interesting. I'll save that one for another teardown. And check it out. It's not a power adapter, it's a power adapter. Made in China. Oh man, it's going to be a shocker. Save that for next time. Thank you very much, Sungyu Logistics, and everyone else who sent in everything for the mailbag this week. So thank you very much to everyone who sent something in for this week's mailbag. And if you liked the video, please give it a thumbs up. And if you want to discuss it, jump on over to the link below at the EEVblog forum. Catch you next time. And just a quick note on soldering these LEDs on straight. Make sure you've got a way around the right way, of course. Now you may have noticed I only soldered one leg on there like that. So if you've got one leg soldered, then you can just push on the back like that, heat it up, push on the back, and you can then individually center each one perfectly, push flush on the board, because otherwise trying to get them all aligned on the bottom, there's many different techniques you can use to do this, but that one will give you perfect alignment on each LED. Once you've got each LED perfect like that, then have I got them all the right way? I think so. Then we'll just go around and we'll finish off the other leg of each device, and we'll be all sweet. Got to do more videos where I just solder kits here, and I can add some commentary too if you like that idea. Got plenty of kits to assemble. Maybe I should just sit down and solder them and give some commentary. Almost done. And of course, when you're trimming component legs, you may have noticed that I was holding my hand over them. I'm not doing that to cover what I'm doing. I'm doing that because these legs can fly everywhere, including into your eyeball, and that will ruin your day. Trust me. So always hold these things or put your hand over when you're trimming like that so they do not fly up into your face. Last but not least, we've got surface mount battery contact. All right, will it work? There's only one way to find out. This could be incredibly embarrassing, but let's plug it in. Hey, there we go. We have an LED. I don't like the non-diffused LEDs. I'm much a fan of the clear LEDs. I'm much prefer the diffused type. So let's press the button. Oh, there we go. Boing. And what are we at? 1. Ta-da! It's thinking. Oh, 5. What? 5. 6. What? It's jumping all over the shop. Does it slow down or something? We've got 4. 1. Oh, right. Is it the length of time you hold your finger on there? Okay, there you go. So it's... And it slows down. 3. Finally stops. There you go. Bingo. It works. Beauty. Of course, the only problem with this board, you don't want to touch under it. You don't want to hold it. Be all over the shop.